Okay, number 2, where we left off. We had our 3 forces we were about to add together to get our net force in the y direction. The y component of this 200 Newton force, which is 173.2, the full 200 of the middle guy because it's acting straight down, and the y component of this 200 force, which is 173.2. So when we add those 3 together, we should get 446.2, nope, forgot to double the 2, 446. So 446.4 newtons. Okay, and so that's our F net, which means that will also be our FEQ. The F net will be acting downward, the FEQ would be acting upward, and it would be this big. Okay, the last one. Now the last one you may have thought was a little crazy, but it's really not that bad. Might have enough room. And it's all about if you draw it correctly. Okay, so let's see if I have enough room. So do your XY axis, and it says 6 forces on a central object, or act on a central object. Force 1 is 300 newtons acting at 30 degrees. So 30 degrees would be about here. And this is 300 newtons, 30 degrees. Force 2 is 200 newtons, 60 degrees. So 60 degrees would be about here. Not going to be quite as long. 200 newtons. And this is 60 degrees. Okay. Force 3 is 500 newtons at 135. So 135 would be all the way over here. And 500 newtons. I can draw better straight lines when I'm not holding the iPad with one hand. So this is force 3, it's 500 newtons, and this whole angle is 135, which means the angle inside there is 45. Force 4 is 300 newtons acting at 210. So 210 will be over here, going this way. That's 300 newtons. 210 means this angle would be 30 degrees. Force 5, 200 newtons at an angle of 240. So this will be 200 newtons. 240 means this angle. Sorry, is that better? This might have been before I made it blurry. It means this angle in here is 60 degrees. And then the last guy is 100 newtons at an angle of 315. And 315 is going to be here. This is 100 newtons, and that means this angle is 45. Okay, so if you draw it, you might notice that the two 300 newtons are directly across from each other, and so they're going to cancel each other out. The two 200 newtons are directly across from each other, so they're going to cancel each other out. So the resultant is just the 500 Newton force going this way and the 100 Newton force that happens to be going exactly opposite. So because they're at opposite angles, you could just subtract them, and the resultant will be 400 newtons. Subtract and keep the direction of the larger, so at an angle of 135 degrees, and you are done. Isn't that fun? Now 4 and 5 might be a little tougher, but try them over the weekend and we'll get back to them at the beginning of the week. The one other thing I wanted to talk about was your question number 18. Okay, so this one that you have due on Monday. So it says an express train traveling 36 meters per second. So VI is 36 meters per second. Gets sidetracked accidentally onto a local train track. This express engineer spots a local train exactly 100 meters ahead. So if this is the express guy, then 100 meters ahead is the local guy. Okay? And I want you to do this question exactly the way the question asks you to, and don't come up with a new way on your own. Okay? I want you to do it the way it's asking. So the engineer jams on the brakes and slows down the express train at a constant rate. So A is going to be of 3 meters per second, and it's slowing down. So that'll be a negative. if the speed of the local train is 11 meters per second, and it says the local dude, he doesn't know what's going on, so he doesn't step on the brake, step on the gas, that's his VAV. Will the express train be able to stop? So in part A, it's so to stop, VF is 0. Will the express train be able to stop before it hits the local train, or will there be time? Okay, so then it says to solve this problem, take where the express train is as your origin. So this is your point 0, okay, which means your local train starts at point 100 meters. And calculate how far each train is from the origin when the express train stops. So take a look at your givens here. For your express, you can find delta t because you have VI, A, and VF. So find delta t. Then use that delta t and find out how far has the express train traveled in that time and how far has the local train traveled in that time. Well, with our givens, for the express, our delta t will be VI delta t, 1/2 A delta t squared. And for our local, it'll be VF delta t. And remember, the times are going to be the same. That's how long each of them have to stop once they're spotted, the local 100 meters ahead of the other. But because the local's 100 meters ahead, once you find the delta t of the local, you have to add on the 100 meters to figure out from the origin will these guys hit. So you get these two numbers, you check them out. That's part A. Okay, so part A says, based on your above calculations, would you conclude that there's a collision? So you need to conclude whether or not there is. Then part B says, to verify your answer and to assure there's no collision taking place before the end of the 12 seconds, which may or may not be the answer to this part. Calculate the position of each train at the end of each second after sighting until the express train stops. Make a chart. So it wants you to do a chart like this. It wants you to put express here and local here. And it wants you to find out how far did they travel in the first second, in the second second, in the third second, all the way up to the 12th second. Okay, so you're going to take 1 second, fill it in for the express, get your value, put it here. 2 seconds, put it here. Then go over here and do the same thing for the local. Remembering for the local, you have to add the 100 meters on. Okay, so you're going to have a chart with all the times in it, right up to the 12 seconds. Then it says, plot these positions on the same graph and draw the two lines. So then it wants you to do a graph, full page, of course, and on graph paper, of course, putting delta D here, delta T here. Plot the express points. Okay, connect them in a different color. Plot the local points. Connect them and see if they collide. And part C says, based on your graph, was your answer to part A correct? What can you conclude from your graph? Okay? Remember, this graph needs to be not like what I have right here. It needs to be on graph paper, and it needs to be the full page. Okay? And it's to be handed in on Monday. All right. Have a good weekend, and feel free to, well, not feel free. You should work on your lab write-up over the weekend, too. We'll discuss it on Monday. Okay.